Okay, so I'm going to be presenting about enzymes for my biomolecule part of the project. Enzymes are necessary for the cell, and they are made of proteins, which are polymers, and those polymers are made of smaller units called monomers, which are amino acids. And if we have different varieties of amino acids, we have different polymers, so proteins, and then therefore we have different enzymes. So what I'm trying to get at is with more variety of order, I guess you could say, more pairs or orders you can make, the more enzymes you can make, and the more variety of enzymes you will, I guess, have access to. Really, the cell will have access to. Just an example right here. This is an amino acid. Hopefully you can see my mouse. So everything above this letter R is usually constant in amino acid. The letter R is a variable that changes in some molecules, which is where we get our variety. Enzymes are catalysts, and really that means they make, really put simply, they make reactions much easier. Normal chemical reactions without enzymes usually take up or require more energy to even just begin it, whereas enzymes make that chemical reaction happen with less energy. So I have a step-by-step process, a really simplified step-by-step process, where a substrate or a molecule will fix onto an enzyme in its active site, where the enzyme will begin its reaction will begin its reaction on the molecule, and the molecule will split into however many products the enzyme splits it into, and those are called products. And that reaction is much, much faster than what the reaction would have been without the enzyme. Right here on this graph, I still don't know if my mouse will be seen. These are the reactants right here, and if you follow the red line, it follows the energy over here, which goes significantly up and then finally crashes all the way down to the end part of the products. And if you follow the dotted red line, that's the same chemical reaction, but with enzymes instead, where it takes considerably less energy to do the same chemical reaction and end up with the same products. So really, it's clearly an advantage, clearly a convenience, and pretty necessary for the cell. Some examples that humans use, or just cells altogether use them for digestion, some DNA replication, and just in general, they speed up chemical reactions. Enzymes can be denatured to alter its shape, which is really bad for cells that need enzymes so they can execute chemical reactions faster. And right here in this little picture on the bottom left is a denatured enzyme which has an altered shape, and the substrate above it is trying to fix onto the active site of the enzyme, but simply can't because it's changed its shape. It's been exposed to too much heat. So processes can't be carried out in the cell, which is incredibly bad since they have to take in more energy to just do a chemical reaction. Usually you want to stay away from hot temperatures when to avoid enzymes denaturing, but also fevers are especially the bad part of this. They will, since the heat is more internal than external, if you have a fever for long enough, they will denature a good chunk of your enzymes, and lots of processes can occur, and eventually, just quite gruesome, but you will die. Hey, don't, please no. So, those are enzymes, and thank you for listening.